Great. Okay. So our next presenter is Yash, and he's from Ryerson University. So thank you for joining us. And so Yash, after completing his Bachelor of Applied Science from Waterloo in 2018 and Masters of Applied Science in Building Science at Ryerson in 2020, Yash has decided to continue on an academic trajectory by pursuing building science PhD program at Ryerson again. Yash has 3 years of industry experience working in sustainable infrastructure, stormwater management, and building restoration. In his PhD research, Yash focused on sustainable infrastructure by the use of novel materials and passive strategies. So I'm going to stop sharing my screen, and Yash, it's your turn. There we go. I'm going to mute myself, stop talking.
Great, thank you. Just hoping you guys could see this. Awesome. Oh, there we go. Hello, everyone. As Noah said, I'm Yash, and I'm just starting my PhD, so this is a preliminary step in order to get my PhD across, but it will be focusing on hydrothermal analysis of cross-laminated timber, and I'll be looking a little bit more on that. For today, just a little, for learning outcome, it's just about a little bit of background on cross-laminated timber, and then the importance of hydrothermal analysis of CLT specifically. In terms of the CLT, CLT consists of several boards, which are placed crosswise or orthogonally, typically glued on the width of their width faces, and sometimes short faces as well. So by width, I mean cross, and sometimes short, meaning these ones across. And CLT panels can be ranged from 3, 5, 7, and 9 different types of layers. The layer thickness it really depends on what you're using it for and where you're applying the material. Sometimes it's the material can be used to be either first floor, floor slabs, roof. It has been used for roof in previous occasions. It has been used on siding, and it basically can replace. It has the potential to replace concrete. In terms of CLT history, discovered in mid-1990s, Austria, we see a lot more gain in North America starting 2005, 2010-ish. So it's relatively new, especially because we haven't had that much of hygrothermal research over here. We have had in North America the structural integrity, fire safety, and seismic vibration. And future areas of study should be hygrothermal research, detailed design, and construction feasibility. The part that I'm focused on is hygrothermal research. So the importance, why hygrothermal research is very important, is because overall this product is made out of wood. If you have water in it, there's going to be moisture transfer, there's going to be heat transfer. And at certain point, and what ends up happening is with certain type of temperature, certain type of moisture content, you end up getting mold, i.e. that is bad. Therefore, it's that's the whole purpose of doing this research. A part of this research is material characteristics. The reason why material characteristics is really important is because you need to understand how the materials work in order to simulate anything for long-term effect. The second part is obviously durability, which is moisture and temperature cycling, mold growth, and long-term performance. In terms of my hygrothermal research, the material characteristics that I'm particularly looking at is temperature-dependent moisture absorption, temperature and RH-dependent vapor permeance, temperature and moisture-dependent thermal conductivity, wetting and drying cycles. All of these are important, but they're not the focus of the research. The focus of the research is creating a simulation tool that we can predict hygrothermal modeling through. So step one, which I'm working on right now, is creating a simple ODE through Simulink and MATLAB. And I'm currently in the model verification phase. And step 2 would be taking that model a little bit forward into PDE through model development, model verification, stress testing on PDE using field data, because the industry partner, TRCA, that I'm working with, I will be getting field data live. So basically using that field data and part 2 and the material characteristic, I should be able to generate a predictive model. That's the overall goal. And that's pretty much what the research is all about. I try to condense my slides as much as possible into 5 minutes because that was the timeline. So that's pretty much all I have. Thank you. Are there any questions?